Hey, hello, welcome to the show. It's me, John Park, and we're here in my workshop. Thanks for stopping by today. We've got people over in our chat. If you're interested in joining in the chat and you're wondering where it's at because you're on Twitch or some other place that doesn't seem to have an active chat, head on over to our Discord, which is at adafru.it/discord. That's adafru.it. That's our URL shortener. And look for the live broadcast chat channel. That's this right here. Hello to Andy Calloway and Paul Cutler and Thin Man. Thanks for stopping by over there. Hey Dave Odessa over in our YouTube chat. I do keep an eye on that one as well. Thanks for stopping by, and let's talk about what we've got going on today in the workshop. So first of all, I got a coupon code for you in case you want to save some money on some neat stuff from the Adafruit shop. I have a recap of the Tuesday show, which is my product pick of the week show. I've got a CircuitPython Parsec for you. What else? We've got a update to, or a modification, a safety check for last week's project, which is the air blaster. I'm going to add in a couple of components so that we have a pressure relief valve, which I had talked about and then kind of spaced on when I removed the original gauge that was on there and bike hose that was on there. That's where the relief valve was, so I'm adding one in. And I'll update the guide with that, but I'll show you the circuit and software side of the guide. Last week I showed you a preview of the assembly portion, the build portion. The 3D modeling / CAD segment I've got working better than before. I've made some changes to how I'm capturing my 3D software, so that should actually give you much smoother playback and still be able to see the cursor and things I'm clicking on. So I think that'll be helpful there. As always, let me know in the chat if you, I don't know, happen to notice my audio disappears, because I do that a lot, or if you have questions, if you have tips, if you have suggestions, things you'd like to see in the future for any of the segments, please let me know. This is our show together. It's interactive. Andy noticed Lars back there. What are you up to, Lars? Looking a little suspicious, Lars. All right, so coupon code. Hey, look, I know we're getting started early on the Halloween stuff, but not that early. Make sure you go out and get yourself some candy corn if you like candy corn. But either way, you're going to have to type that in, even if you hate it. Sorry. You're going to have to type in candy corn in the coupon field on your way out of the Adafruit shop if you want to save 10%. You can head on over to adafruit.com, and it looks like that. You'll see we've got some cool little banners there you can click on and see what's going on there. We've got a few highlighted new products. We've got a gift guide, as well as you can click on View All New Products and see what's the latest. And you can use candy corn as your coupon code to get 10% off. And that'll work pretty much on anything that's physical that you can have shipped to you. We don't apply that to software or gift certificates or subscriptions, but it is good on physical things. I'll also mention that if you want to get a bunch of stuff and you'd like to layer on top of that some free stuff, then spend a bunch. That's how it works. If you spend $99 or more, you'll get $99, that is, $99 or more, you'll get the free PCB coaster. If you spend $149 or more, you'll get the coaster as well as a free KB2040 microcontroller, which is perfect for all kinds of USB projects, particularly keyboard and USB HID projects, but it's great for loads and loads of other cases. We have at a $199 or more price point, you can get free UPS ground shipping in the continental US, as well as the KB2040 and the coaster. And if you spend $299 or more, you'll get a Circuit Playground Express and the UPS ground shipping and the KB2040 and the coaster. So that's all for different price points. But if you want to, regardless of that, save a little bit of money, candy corn, that is the coupon code today, and that'll get you 10% off. I have not yet gotten any candy corn, even though I'm starting to wear autumnal colors. I need to get on that. I have not yet had candy corn this season. Next up, I've got a show on Tuesdays that looks like that. It is my product pick of the week show. And on that show, I've picked something new and show you how it works, give you some demos, and a huge, huge discount that's just applied during the show. It's a live show streaming from inside the product page. Here is the recap from this week. It is the I2S stereo decoder breakout. It is the UDA1334A, which we thought was gone forever, but now it's back. This is an I2S stereo decoder with a line level output over a TRS 3.5 millimeter jack. I'm going to send 4 notes, sine wave, saw wave, a triangle wave, and I'm playing them back and forth. So I'm going to be panning them back and forth. These are the outputs on the I2S stereo decoder, and then those are going to those pins on my Pico. I just have that. This is the I2S stereo decoder with the UD1334A. Yes, that indeed. There it goes. That was product pick of the week this week. Really great decoder for I2S stereo applications. And I didn't really mention there in that bit, but it is also an excellent one for cases where you don't have clock, such as a Raspberry Pi. It does not rely on the microcontroller or the single board computer providing clock. It can do all that on its own. All right, next up, let's do a little CircuitPython Parsec. CircuitPython Okay, pardon the glare there. I've got a bunch of lights. But on the CircuitPython Parsec today, I want to talk about getting the distance between 2 points on a touch screen. So this, first of all, I'd like to say was inspired by the Spirit board, Ouija board type of project that Tim Foamy Guy just released recently. Super cool project. And I was looking at it and I said, hey, there's a bunch of neat little nuggets in here. I'd like to bust out a couple of them and show them on their own. So one of the things he does in that is figures out the distance between 2 points on the screen so that he can then move the little planchette, the little cursor essentially on the project. So what I'm doing here is I've got a Pi portal, and you can see when I start this up, it says touch the screen twice to find the distance between points. So I'll touch once and you'll see it spits out both in my REPL and on the screen there. Point 1 is at 272 on the x-axis and 40 on the y-axis. And then I'll touch a second time and it says point 2 is at 34 and 175. The distance between those is 273 units. So that's roughly pixels, I think. In this case, it's also more accurately touchscreen units. And I'm going to play around with this in future episodes and determine exactly what units we're looking at there. But the main thing here is that we're able to use the Pythagorean theorem to determine the distance between 2 points on a 2D plane. The way this is done is I'm importing the time, board, math, and touchscreen libraries. I initialize the touchscreen, and then I have this function. This is the key thing here. This is the Pythagorean theorem. It says function is dist in, and then we have two inputs, point A and point B. Those are tuples that have the x, y, and pressure. We don't really need the pressure, so we're really just going to use the x, y of two different points. And then you can see here it says to calculate the distance between the 2 points, the tuple point A is the xy pair of the first point, and the B is the xy pair of the second point. So we are then casting AX, that's first point X, and AY, that's first point Y, as point A. I'm also grabbing the pressure there, even though we're not going to use it. And then for the second point, B on the X and B on the Y is point B. And then this is what we're returning. The integer of math.square root of second point x minus first point x squared plus the second point y minus the first point y squared. Did I say that right? I'm going to say it again just in case I didn't. Math square root bx minus ax squared plus by minus ay squared. And that gives us the distance between those 2 points. Then in the main loop, all we're going to do is check for the screen being touched. If it gets touched, then we take the P1 variable and switch it from none to being whatever that touch point was, and we print that out. And then we just have a little debounce time in there. We look for a second press in case P1 has already been touched. Then we know as the state of that, we can fill that second variable. So P2 is equal to the touch point, and then we go ahead and say distance is equal to this function up here, dist point A, point B. And then we print that out, and I'm doing a little bit of fancy interface stuff there to put a number of dots that's equal to a tenth of the actual distance number, just because we don't have enough screen space to do the actual distance number without looping that a bunch of times. And so that is how you can get the distance between 2 points on a touch screen inside of CircuitPython. And that is your CircuitPython Parsec.
CircuitPython Parsec.
Oh my goodness, thank you, yeah. I didn't turn the mic back on. How has that become my latest fun habit, huh? What I said was, thanks to Tim, Foamy Guy, for posting this code in this Learn Guide, very cool Learn Guide for the TFT Spirit Board. It has a lot of nice snippets that we can use for some different things. I think I'll expand this one, not just knowing the distance, but doing something with it, like creating something like a circle that's the size of 2 points that we press, or if we want to do some motion between points, we know the distance that we have. So some neat stuff in this TFT Spirit Board guide in the code that I thought might be nice to break out a little bit. So thanks, Tim. And thanks to everyone in the chat for letting me know that I left my audio off, because your little bidoop bidoops when you message actually catch my attention. So thanks. Hey, Dale Etchels, thanks for joining us over in YouTube as well. And let's now move into, why don't we take a look at, speaking of, oh, by the way, I thought this was a nice explainer here on Pythagorean theorem. This is essentially the math that's going on there between two pairs of xy coordinates to get that distance. So you can look up Pythagorean theorem to find the distance between 2 points, and that's what's been implemented in that little function. Also, I will say there was a nice live stream that Foamy Guy did during development of the Spirit board. You can find that on our YouTube channel, and it's neat to see Tim work through the process of getting the right formula to do the distance, and then doing some interpolation between the points to be able to do motion between 2 points. So really cool stuff there. Good old Pythagoras. Okay, so next thing I want to do also here in Learn is go over a couple of new sections to this guide. The guide is live now for the Haunted Air Blaster. You can see a little piece of that air tank over there. I've got a movie and a little GIF there that shows it in action in a little haunt setup, just scaring the heck out of people by moving a skull and a purple feather boa around. Last time I showed the parts breakdown and the assembly of the hardware, the tank itself, and then since then I also documented and posted here and put the guide live the circuit. So there you can see what this thing is comprised of. Is a Feather RP2040 prop maker. By the way, I'm not using this to anywhere near its full extent. One of the reasons I picked it is because you can integrate NeoPixel LEDs pretty easily into this, servos. It has an I2S amp if you want to do some other sound stuff. So I think it's a good platform, even though in this case we're really putting most of the duties onto that feather wing, the power relay feather wing, which is what's allowing our 3 or 4 amp 12-volt signal to run through and open and close the solenoid valve. But that's the 2 feather-sized boards I have on a feather wing, and then we have the VL53L1X time of flight distance sensor, which can go up to 4,000 centimeters, so I don't know, 10 feet or so. You can get pretty good distances out in front of it that it'll notice someone moving, so it's a good one for this type of project. And then I've got a capacitor there to prevent the EMF back current from resetting the board. So that's the fritzing. Here is a schematic of the same thing. The schematics in fritzing sometimes are a little funny, like this barrel jack is ginormous, but this sometimes I think is helpful for people who want to know pin names a little more obviously versus the fritzing diagram, which is more representational. Okay, I have to show this for a second because that's terrifying. Why? Okay, so there's our assembly instructions. It's pretty simple. It's just soldering on some headers onto the feather wing and the doubler and the feather itself, and also setting pin 10 to be the pin that'll be triggered on the relay from the feather. So just keep in mind, if you get one of these, I think any of our feather wing relays, by default, I don't think they have any pin jumpered, so you'll think it's not working. You won't know what pin to use. You're always going to want to jumper one of these. So in this case, the one I've jumpered there that happens to be pin 10. You can kind of tell from the traces or look at the guide for the power relay feather wing to find out which jumpers correspond to which digital I/O pins. And then we plug them together. We set up a little circuit here for plugging in the 12 volts, adding the capacitor, and then running to the power relay as well as the solenoid, so that uses two of these little snap link connectors. And that's what it looks like once it's assembled. So you can see we are running the ground directly from the 12-volt power supply over to our one block and then the capacitor. And then on the other block we have the power side, 12 volts running to the common terminal on the feather wing, and then the normally open side, so that only gets closed when the relay is tripped, goes to the other of those two little snap connectors that I'm using, Wago connectors. And then into that we feed the two wires from the solenoid, which happens to not be polarized. You can energize in either direction and it still charges the electromagnetic coil enough to lift that slug in the middle. So here it is with that set of connections made. There we go. So there's the solenoid running to the two sides. One is going to get the ground always, and the other is going to get the power when the relay allows that power through. And recommend doing a little bit of a test there. Since you're not having to solder things together, it's all these little snap links for the wire. You can assemble it, test it out, and then just disassemble two wires basically to be able to put it into your enclosure. So I'm using one of these nice little waterproof enclosures that has cable glands. Here it all is fit. Oh, there's the wiring coming through gland there. Here is everything stuffed in there. It fits pretty well. It's snug enough that I didn't bother with any tape or screwing it down. It shouldn't be getting moved too much either because we're going to attach it to the tank, so it's not getting jostled around or anything like that. Excuse me. And there it is with the lid on. I lost one of the cable glands somehow, so that's why three of the wires there, which are the USB power, DC power, and the stemma QT cable for the distance sensor, those are running sort of unceremoniously into one of the holes there. And then you can see here, I've just used a couple zip ties to attach that to the handle on the top of the tank. And then we've got a page there on the code for it, which I think we've looked at before. And then a little usage guide here. So there you can see we're going to take a air compressor, attach it with a little quick connect to the end, open the valve, turn it on, fill. We can watch the pressure gauge there. I put it up to about 60 or 80 psi. Tank is rated for 150, I think it is. So the safety valve, the pressure relief overpressure valve that we're going to add to it today, I think I got one that's rated for 125. I'd just like it to fail before we reach the limits of the tank. I think that's wise versus getting one that's exactly 150, because these things are pretty variable. It's just one spring. The strength of one spring is what's determining that pressure. It's a low-cost safety item. And then here's the prep for it. So we, once we've filled the tank and we're ready to use it, we can open. Actually, what I'll recommend here is close the output valve. So we have a ball valve for output. Turn that off, and now we can open and close the solenoid just as a test, electromechanical test, without pressure going through the system, without firing. Once you're satisfied about that, and that's where you might go in with code and adjust the distance, and then you can just listen for the clicks of the relay and the solenoid, and there's a blinking light on the top of the power relay feather wing. Get all that worked out, and then you can open up the valve and be ready to go. And then here was my sort of example setup here. I have it kind of tucked away, and the direction you're walking is sort of parallel to the tank, so you'll trip that perpendicular distance sensor, and it fires sort of out in front of you, not at people. Don't shoot people with this, please be careful. And you can dress it up with some weird Halloween stuff you find in a bin. And there's another shot of it, and here it is kind of dressed a little more. Obviously, I'm trying to show the tank here, but we would hide this. You can just use a little bit of cloth or something like that. By the way, you can also disable there's a jumper you can cut for the distance sensor so that the little green LED is not lit. If you don't want people to kind of notice that they're walking past a trip line sensor, then I think that's a good idea. All right, so now let me know if you have any thoughts or questions about that much so far, but what we're going to do is update this with some safety that I'm forgetting the viewer that mentioned this last week that I had said, I hope you didn't remove the safety pressure relief valve, and in fact I had. So here we're bringing it back, and I'm gonna just arrange my windows here so you can see. And let me just bring up Discord so that I can see the chat. And there we go. Okay, so what's going on here? This is how I had it built, how I have it built right now in the guide. This is the quick connect for the air compressor to come in, cut off valve so that we can charge it and then close it. You can see here I've already loosened this. And then we have a pressure regulator and gauge so we can see what we're pressurizing the tank up to. And it is not a new camera, Andy asks. There's a chance that, knock wood, that one isn't going to be turning itself off anymore because I think it was not overheating. I think it was a really loose power connection and the battery that's in it is basically dead. So it's kind of always in a weird charge USB mode. And it's just a dinky little USB micro B connector. So I think that's my issue. I tightened up some little stress relief, strain relief that I have on there, and crossing fingers and knocking wood, it's gonna not be shutting off. So let's see. So what I want to do is from this point right here, kind of anywhere after this point to this point, we can measure pressure with a strain relief or a overpressure relief valve. And this one, like I said, is rated for 125 psi, which essentially there's a spring and a valve, and if the pressure gets more than the spring can deal with, this lifts up, and you can pull it with a little ring to test it, but it'll out the sides. So this, anywhere kind of from here to here, will mean that if the pressure got crazy high in here, and the main reasons for this, since we have a regulator on here, and I actually don't have a super high power compressor, I think my compressor only goes to 100 psi, so I'm not in danger of charging it on my own too high, but what could happen is it could get heated up. That's one of the concerns. If it's a weather thing, if it's a fire, if it's a propane torch, who knows what, you don't want this to be a bomb. You don't want this to explode from overpressure. So the idea here is this thing will let off pressure after it gets past 125, roughly, psi. So what I think I want to do is, I don't want this to get any longer. This kind of extends pretty far. So what I wanted to do is get a T valve, pipe T, and rearrange things so that we have, I'm going to get rid of this longer pipe nipple, I think, connect this here, connect my pressure relief here, and connect the inlet and valve here. So we're going to go a little sideways here thanks to this. I debated using a couple of U elbows or 90-degree elbows to kind of wrap it back around itself. It's a nice way to make it more compact, but I decided this will be enough, and that means that this will live not way out here, but further down. So I already removed that one. I'm going to pull this longer pipe nipple that I don't need from here, and this valve has a hex connection on it, so I should be able to hold it. You don't want to grab this here by hand, as tempting as it is. It's better to get a wrench and a pipe wrench, and then we can remove this. I have already put some Teflon tape on these and then just hand threaded them onto there to make sure that this arrangement would work. And then what I can do is probably this is where I'll start. Or, yeah, that might work. Just got to figure out where I can hold things so that I'm not bumping into stuff. That might be good. It might leak. We'll find out. But I think that's probably in there pretty good. We can always grab it and give it another turn. I'll leave this guy here. These come with, I didn't need to put tape on it, these come with a little sort of rubberized goo on the thread. So we'll put that. Okay. Crank that back like that, and then this is going to go here, and hopefully I can get it somewhere where I can still, so I've got to kind of thread it to where we can still open and close that valve. Easier said than done. Let me give this a little hug. There we go. Okay, so now it's, see that a little better there. Now we've got this, and I'm gonna put my wrenching to the test here and actually pressurize the thing. It may be worthwhile to spray some soapy water or proper leak checking solution on there, but I'll give this a shot. You can, after I charge it, I can close this and listen for leaks too. That'll give us an idea, or if it's terrible, I'd see the valve change there, so, or the gauge change there. So let me turn on a compressor. And you can see the needle there. right, so I'll remove that airline, and it's silent, so that's a good sign. What I'll do also with these is just leave them for like a half hour, note the pressure, and then just make sure that it hasn't lowered. But that makes me feel a lot better about this, because now we have a pressure valve on there, or a pressure relief valve on there. We can open that, so now it wants to, air is being stopped only by the solenoid. I'll give that a close, and I'll plug it back in just so we can give it a full proper test. And let me plug in USB for the feather. There, you can see that blinking and coming to life. There's my distance sensor. So you can see it's doing its little trip and dance. I'm going to aim this away from things for the most part. And now I'll plug in the actual 12-volt power. Andy says the camera seems clearer than usual. I didn't even wipe the lens or anything. I don't know why it is. So this should now trip the solenoid. I still haven't pressurized it, but we'll hear that go click, click. Okay, there's probably some little amount of air trapped in there that we heard on the first shot. Now I can open this, and for a visual demo, I will just put some paper over the end. See that get launched. God. You can see I adjusted the timing. Last week I was playing around with some of the timing, so I have those little 5, they're so short that almost no air gets out, so that just gives us like a little sound effect versus the first and last ones, which are bigger blasts of air there. And you can see after a few shots there, we're down from, it was at about 38, and now we're down to around 32 PSI. So this doesn't dump that much air. We get a lot of shots out of it. Closer to 28 or so. And I think that'll do it, yeah? So let me know in the chat if you have any questions about that or comments. This is our safety. It's actually a nice size. It's 1/4 inch. The one that was built into the original hardware that came on the air tank was the smaller, I don't know what size these are, these little smaller sized relief valve, and it was kind of integrated into here, and a smaller cutoff. This is 1/2 inch, and that's what matters. All this is, I think, might be an 1/8 inch for these ones. So bigger relief valve, bigger spring, but rated to 125 PSI. All right. Let's wrap that up. So I'm going to unplug this and head back over. And let's note the pressure. We are at 25 PSI, so I'll check that like in an hour to see if we're still at 25 PSI. I will, in fact, take a picture of it because I'll forget that otherwise. I guess I could watch the video, but I'll just take a picture of that gauge and unplug USB. There we go. One thing I'm interested in doing with that, now that I've got that built, is try to make it loud. Like for somewhat different, this one's meant to like puff stuff around, but I think you could add a larger air resonator to the end and get a lot of noise out of it. Maybe swap out that long barrel for a much closer coupler to like a 1/2-inch pipe or something, or a tin can or something like that. Questions in the chat. Let me get that thing out of there. Over in YouTube, hey DJ Morph. They're getting their jumper out because it's getting cold. Excellent. David Essa says, is the safety valve adjustable? I think that one's not. And now we'll never know because I don't want to unscrew it. Some of them will have like a set screw on the inside, like a big, use a slotted screwdriver, and there's a ported set screw that you can adjust to some amount that spring, how tight that spring is. So I guess as you tighten it up, you're giving the spring more tension, so it'll open on less pressure. This one I don't think is. It was like an $8 one, so I don't think they bother with that in there.Maybe they do, but I believe it was just a fixed PSI. Didn't say adjustable. But yeah, I think if you wanted to do more testing and needed an adjustable one, you could do that. But I think this one will do the job. Oh, Andy says attach a smoke machine to the outlet. Yeah, I have never tried that, but I guess you can feed some fog smoke in and get that to blast out. You can just hit, if you have a big thing of fog, you can hit it with this air. I think you can integrate mist into this as well. If you look on prop haunt kind of websites for effects, you'll find some that are made, they call them spitters or sprayers, and they'll spit out, gross liquid out of skeleton mouths and stuff like that. So you can do a lot once you get that kind of basic setup going. And you can do it at lower PSI too. There's nothing to stop you from running everything at lower PSI. Hi DJ Morph. You can also get bigger tanks. So this one is a 5-gallon tank, but it doesn't cost that much to double your size or more, depending on what you're planning on. But another advantage of these is you're not running a compressor motor all the time. If you think of your average little shop compressor, they don't hold that much. They're like a gallon or something, and they're just going to run all the time. This won't run until you run it yourself, so it's not going to spoil the illusion. And you can run a long line if you want air line to it, so you can fill it from somewhere remote, so it's not as noisy. Okay, let me move this here and bring this here, because I think I got a good method of sharing the 3D modeling screen at a way better frame rate. So this should, unlike the two ways I tried before, one was slow frame rate, but you could see the cursor. The other was you could get fast frame rate, no cursor. I think I found option 3, which is better for seeing what I'm clicking on and actually seeing stuff not stutter quite so badly. So this is my segment on some 3D modeling and CAD basics. Last week, let me pull up my notes, we went over some 2D and 3D primitive objects, squares, triangles, stars, hexagons, 3D pyramids, 3D cubes, 3D spheres, those kinds of things. Working with curves a little bit, including splitting curves with other curves, joining them, making nice rounded transitions between curves, something that's called a fillet. And then taking our curves and turning them into 3D objects, first with something called a revolve or a lathe, looks like a pottery wheel type of effect, and then also sweeping around a more sophisticated rail shape. So you can catch up if you missed any of that and want to see it in last week's show. This week I'm building upon some of those ideas, and we're going to start off with something that I really dig, which is a more convenient way to do this curve splitting called a curve Boolean. So what I'll do, I'm going to start off with a rectangle, and I'll do some snapping to the grid with this for my start point. It's kind of at the 0, 0 origin point on X and Y. And I'll just type in 80. That means it's going to make it 80 millimeters wide, and I'll do it 60 pi. So I thought, let me actually type enter and then 60. There we go. So I've got a rectangle. Nice. What I'm going to do now is make a copy of this by rotating it and telling it when I rotate a thing, make a copy of it. So what this is asking is what's the center or the pivot point of the rotation. I'm going to use the center of this rectangle as its pivot. So you can see if I drag anywhere around the perimeter of this thing, it's saying you want to use this is the center, or you want to use this is a midpoint or a corner. So I'm going to start from the center, and I'm just going to type in 45. That's going to give me a 45-degree angle, and now I have a copy. So I have a copy that comes from the same point but is rotated 45 degrees. The reason I did this is I want to make a couple of cuts into some corners, and I'd like those to be parallel to each other. So by just replicating this, I have a nice way to do that. By the way, a question I get asked at this point often in doing these the last few weeks is what software I'm using. All of these techniques tend to work in most CAD software and most 3D modeling software. The one I'm using is called Rhino 3D, but you could use these types of techniques in most software. So what I'm going to do now is pick both of these curves, and then I'm going to run a command. And one thing I like, especially for demonstrating stuff in this program, is I'm not clicking around a lot on menus or icons. I'm actually typing in the names of my commands. So I'm going to type in, and you'll see in the upper left corner there, it's filling in some command completion. So this one I want curve Boolean, came up first there. And then the instructions show up right there. It says click inside the regions to keep. So I want to keep that, and that, and that. I'm also going to say delete input. Get rid of anything that we started with, those two curves, the pair of rectangles, and just leave behind the curve that is this area that I've just defined. And I'll hit enter, and you can see now we have this kind of stylishly notched rectangle. Go to a top view for a second, and I'll duplicate that. Just make a copy over here to the side, because I want to show, before we go back and use that one, that this will apply to all different types of curves that you could make. So if I create some sort of freehand thing and run that curve Boolean command again, so I'm just going to grab it from a list of recent commands this time, curve Boolean. Again, it's going to say keep what you want, and it gets rid of the rest. So a neat way to do about 3 things in one, which is I'm doing some splitting of a curve, I'm doing some deleting of excess parts, and I'm doing some joining. So when I click on this, you'll see down in the bottom of the interface, there's a little piece of text there that tells me I have one closed curve that I've added to my selection. So this is nice, because when we start talking about things like CNC and laser cutting and 3D printing, closed objects are good. Leaving points kind of open on their ends is bad. We want things to often be watertight. So that term there, closed surface or closed curve, is a good one to pay attention to. Duplicate that again. It doesn't just have to be freehand curves, and it doesn't even have to be a, let's see, we'll start, how about with a circle. It doesn't have to be overlapping in multiple areas like that first example. So if I pick these and say, again, I'm going to use a curve Boolean, I can keep maybe just that little chunk there. And maybe that other piece will keep around because it's 2 parts that need to intersect or interface very closely to each other. So that technique right there, really love curve Booleans, really nice way to make shapes, rather than if I were to try to build this type of a rectangle and then maybe free form that line that may or may not be at 45. We could make one at 45, but it takes a little doing. And then duplicate that. I don't know if I duplicated that the right distance away from here. Of course, we can do that, but it's more work. So technique works in a little elemental way, but I also am happy to use a sort of convenience function like this. Curve Boolean doesn't just have to be for subtracting. You can add, so you saw me cut away pieces, but we can also do a addition, what looks a little more like adding two things together. So if we say, how about, I'm going to make a little hexagon. Bring it over here. If we do our curve Boolean, I can pick all of the sections. I don't have to leave anything out, and that means we're just kind of keeping the profile or the perimeter of this whole thing and getting rid of that inner stuff. So now we've kind of added those together into just what looked like their silhouette before. Now it's a single object that we can use. Hello in the chat, John Nodge just joined in. Hello. Yes, questions over in chat. Someone asked what software. Is it free to use? It's not free open source. This is commercial software. You can get a pretty good, like, fully featured trial. I think is good for 90 days, and you can get student edition for or education edition for a very good price, which does allow commercial work. It's expensive for the full-blown license. However, it is not a subscription service. You buy it, you have that license to that version forever. Sometimes upgrades have even been free. Sometimes you got to pay each time you go to a new version. But, yeah, I think Devolve said I think there's a 30-day trial. It might even be longer than that. But okay, so next thing I want to do, I'm going to take this and do another variation on the idea of taking one curve and building stuff from it. I'm going to replicate this curve and make an offset inside. So imagine we're making a box that has walls of a consistent thickness. So you might think to copy and paste it and shrink it using a scale tool, and that works pretty well, but for a lot of shapes that will scaling won't actually make a uniform wall thickness between parts. Even though it's a uniform scale, you will end up with pieces that are skinnier and thicker relative to each other. So there's a command for this that kind of breaks it into pieces, moves them, trims them. Again, a convenience function. It's called a curve offset. So I'm going to pick my curve, do an offset, and you can see here I'm heading in or I'm heading out. And you can see it's almost pretending like we were doing this the manual way by busting this into individual polylines and then trimming them. It's showing us what it's going to do. That's just behind the scenes. I'm going to say, hey, let's make this 3 millimeters. And actually, you can see that's 3 grid units on this grid I'm using. And I'm just typing in different amounts. If I wanted this to be 8 millimeters, that's how far it's going to come in. But I'll keep it at 3. And then my other settings here are defaults that I like, which are essentially just going to take all of those pieces and trim them nicely and join them, so we end up with a second curve now. So we have an outer single closed curve and we have an inner single closed curve, and they have this nice relationship to each other of being consistently 3 millimeters apart at any point. So now what I'm going to do is I'm going to take one of these and I'm going to move it up. I can do by hand. I can snap it to things from a front view. In this kind of perspective view, I like to just click the axis, in this case the z-axis, and type in a number. So I'm going to say, hey, let's move that 3 units up. So now I've got one that's up above. And then what I'm going to do is a new command, which is called extrude. So remember we did loft. Take a curve and skin it by revolving it around an axis, or sweep, same sort of thing, but run around some sort of a rail. This is similar to loft, but instead of copying and pasting and skinning, I'm going to do it all in one command. So I can just do extrude curve, and you can see here it's showing me where it's going to put that. I could type in a number. I can do it by eye. I can snap to other things. Let's say we'll do it 40. So I type in 40 and hit enter. So now both of those have been, essentially, the curve has been extruded out, lifted out to be a full surface there. The reason I want to do the two of them at once, and the reason I offset that inner one, is I'm now going to use a really convenient command to turn each of these into a solid. So I'm going to take the first one and just show that on its own. I typed in cap, and let me go to a ghosted view here so you can see the insides a little better. So you can see I have a solid for that bigger one, and I'll do the same with this inner one. Cap. So now I have two solids. If I go back to a regular shaded view, you can see there's a solid inside of a solid. And now, just like we talked about doing a curve Boolean, which, to back up a bit, a Boolean operation is essentially a add, a difference, or a union of objects, which turns multiple things into some subset of or superset of the originals. So I'm going to take one, and I'm going to type, pick the outer one, and I'm going to say Boolean difference, and it says select the surface to subtract with. So I'll pick the inner one, and I've got delete input checked, which is good. I want to get rid of it. So now I've just carved one with the other. And that's what you can think of a Boolean is a carving, in this case, a solid carving out another solid. You can, let me show some other examples of that before we come back to this thing. And this thing, by the way, is sort of vaguely, I'm making like a little 3D printable case, let's say. So I'm going to, for like a microcontroller or something. So I'm going to just come off to the side here for a second and make some other objects. So here's a box. Here's a sphere. Oh, I need to actually pick a sphere to make. There we go. Center and radius. So I will snap to, let's say, the middle of this thing and create a sphere. And now I'll make a couple of copies of this to show some different Boolean operations we can do. A few copies. So let's do a Boolean difference. We cut that out, so now you can see we have a cube with a little sort of sphere indentation. We can use the box to cut the bottom off of that to make kind of a dome. We can, those are both Boolean differences. We can do a Boolean union, which will say, let's just turn those two things, which you can see one protrudes into the other, into a single thing. So there's no guts of the sphere in there anymore. That's a suitable item for 3D printing because it's essentially all a solid watertight thing, no intersecting geometry popping through, confusing everybody. And the, let's see, split, Boolean split, we can say that and that. So we used one to split this and this to split that, and we can get left behind for little pieces. Another nice thing you can do is, again, for convenience, let me see, okay, that's still the original stuff, is that they have a Boolean to objects. So if you're not sure kind of which order to pick things in, I got confused there. It's very easy to get confused when you're trying to do these splits in particular. You can pick two objects, and then each time you click, it gives you different possibilities. So we can do union, we can do a split that leaves that piece behind, a difference that leaves that behind, a split that leaves, or a difference between that behind, and back to union. So this is kind of nice because you can just keep clicking, it'll keep going through like the 4 possible options, and you say, oh, that's what I meant. I don't even know which order I should have picked those to get it. So those are some basics of doing Booleans there. And then the last thing I wanted to do with these, so we've essentially taken a curve and done some Booleans of the curve to reshape it. We've done an extrusion, we've capped those to turn them into solids, we've used a Boolean to carve out the insides. And then something you'll frequently want to do is get rid of some of these right angles and make things a little softer, because you'll just cut yourself on these. So we've got a couple of orders of that we could have done this, but I'm gonna just do I'm gonna move this off to the side so we can still see our original curves. I'm just gonna do one of these curves after I've offset the other. So I'm going to keep the insides straight, but I want to get a little roundy corner to this curve. So I'm going to go back to my top view. I'm going to pick this, and I'm going to say, essentially, anywhere that we have a corner, which can be defined, I think, as pretty much any acute angle that is larger than the radius of the fillet that we're going to do, or the chamfer, if you're doing chamfers. Go ahead and create the shortest distance tangent to both lines that has a radius that we've specified. Easier to see it than to explain it. So I'm going to pick that curve. I'm going to say fillet corners. We could also fillet just individual pairs of curves if we wanted to, but I know I just want all of these to have a, let's say, a 2 millimeter fillet. And there you go. So it just moved 2 millimeters away from that corner and 2 millimeters away from that corner on Y, and created an arc that is tangent to the two polylines that are coming into it. And it does that everywhere. So you can see this is a shallower one because those were a more obtuse angle there. So I've got that nice rounded curve shape there. By the way, I'm not using history. I'm keeping things very individual. So we can do that, and we're actually going to get into parametric modeling. But right now you can see this is standalone. It doesn't actually know that it was made from these curves before, so it didn't just automatically update. So in fact, I'm going to blow that one away and do the extrusions again. So I'll pick these, and I will do, what did I say, 40? I actually thought that was too big. Let's do 30. Okay, I like that better. I can actually pick both of them and cap them both. And then I'll do my Boolean. So pick this one first, this one second, Boolean difference, or not. Let's try that again. There we go. And you can see now I have that rounded, filleted shape on the exterior. I have hard corners on the interior, which is what I wanted. We could change our mind and fix that in a few ways, but now what I want to do is round these corners or these edges that are at the top. So this is happening not on a curve anymore, but it's the same basic idea. So I'll say fillet edge rather than fillet corner. So I'm filleting an edge, which is a connection between a couple of faces. And radius, sure, 2. I'll use how about half of that? Let's do a 1 millimeter radius. And we can pick individual lines, or we can tell it just pick the whole connected border up here. So I'll hit enter. You can see a nice little preview of what a 1 millimeter fillet will look like as far as how far into the object that'll go. And now I'll hit enter, and we get a nice little roundy round over. These are really helpful in any manufactured object so that you're just not hurting yourself on things. So that is a fillet of that exterior edge. We could do one on the interior edge if we want. So I'm just going to repeat that command. Let me chain the edges. Or not. Okay, you can see here I forgot to press the chain edges. So I'm just having to go around and pick them individually. Sometimes you will do this sort of thing where you'll be picking individual edges. For this, it doesn't make any sense, but you can see that takes a little longer to go around and pick it. This means we're going to use a consistent radius. If you pick one one at a time you can do different radiuses, but then blending between them gets ugly. So there we go. I've got, did it fail? It looks like it succeeded, which is surprising because this is a little tighter in here. No, I think it failed. I think that's too big of a radius for this. So let's do that again, and I'll do a 0.5 chain edges. Pick it just one time. Oh, you're not wanting a chain, huh? Why aren't you wanting a chain? I don't know why. Okay, that's successfully filleted. So I think we can't do a 1 in there just because the corners are a little tighter. If we look at this without those lines, sometimes you can get a better idea of the shape. I'll do some more stuff with materials and rendering so you can see like little specular reflections and things more. John Notch says, it's amazing how much of a difference even a slight roundover can make, for sure. Okay, so let me get back out to a shaded view on this. And then a couple little other additions using basically the same techniques. I'm going to go into a top view here. I'm going to pretend that we have some board like a cutie pie that fits in here, let's say. I haven't measured it, but pretend that's cutie pie dimensions of where the holes are at those corners. I'm going to go and make some little standoffs that we can screw into. So for this, I'll use some primitive objects called tubes, which are essentially a cylinder booleaned out of another cylinder. I can snap to that end there. I'm going to make the the radius of this rather, let's say 1.55, so that's good for like an M3 screw. And then this exterior, I'll make it, let's say 6.5. So that gives us a 7mm diameter of the exterior. And then for a height on this, let's just whatever that is. Now, when I created that, I started it from a top view, which means it was drawn on the plane or the origin grid, which means it's kind of touching the bottom of my object. So we can move it a little bit and Boolean it. That's one way to deal with this. We could have projected that onto the surface rather than onto the grid. We can pick it and move it up. I think I know that I did a 3mm lift on that second curve, so that'll work. We could snap to existing curves if we needed to. And in fact, I'm going to move this thing out of the way so we can see our original curves there. Oops, I want that curve though, so I'm going to go pick you as well and move you over here. Okay, so that'll work. And then I'm going to go ahead and replicate this curve. So there's a bunch of ways to do this, but I'll just use a copy command that'll allow me to snap it to those 4 curves. We can get way fancier and create polar arrays, box arrays, linear arrays, things like that. But that means I've got my little standoffs where I want them. Oops. And then what I want to do is, if you try 3D printing stuff like this, those will likely, or almost any manufacturing technique, those will likely cause you problems because they have this 90-degree angle from the base of the interior of the case, the floor of it, to the object there, particularly with like a FDM printer. That kind of stuff just wants to snap off. So we want to give it a pretty healthy skirt. We're going to do fillet command again. That will give us some material that widens it out at the bottom. And of course, you could have made this as sort of like a pyramid instead, but since we're using that type of fillet technique up here, we're going to do it again just to see it in another context. So I'm going to type in fillet surface radius. Let's make it, let's try 3, not 13. Let's try 3. Pick our objects, and there we go. We get a nice skirt there, gives us more material. You can imagine that's going to be a few layers, 5, 6 layers on your 3D printer, depending on your resolution, of gradual relief there. Now, initially, it's going to, because of the settings I had, trim the floor and trim that tube. Doesn't happen to connect them. I can't remember if that's an option in there. So these are sort of separate pieces. We'll go ahead and join those all together again with our friend Boolean in a second. But I'll just repeat this command for the other 4. And keep in mind, I mentioned I'm not using history to do this. You can see there, it actually, that's too big a radius for living in this corner. So we could kind of make it on a different plane, bring it here, trim it out, cut it off there, or I'm just going to be lazy and make that a smaller radius for this one. So let's just do like a radius of 1 just to get it done. Okay, so that'll work. Keep in mind, I said I'm doing all these as kind of separate operations that don't have history or a relationship to each other. This doesn't know it was originally made from this. I haven't created any sort of constraints or ways of updating this automatically. We'll get to that stuff. I'll show you once we get into parametric modeling with with Grasshopper inside of Rhino. We will be much more like what you'd experience in a typical SolidWorks, AutoCAD, Fusion, these parametric systems that keep relationships among things. So we'll get to that with that. But here I'm going to pick this. You'll see when I pick it, it says we have 4 surfaces, 5 poly surfaces added to selection. I'm going to say join, and now we have 1 poly surface. It said it's open, so I must have some. I remember I was suspicious about when these fillets went in that there was some cracks. I may have not got a joined up line there, so there's probably an issue with this that we could fix. But yeah, right now it's not a closed surface. It should be though. So that is a few sets of techniques: curve booleans, offsets, extruding our curves, capping, booleans of solids, and then the fillet to round stuff over or connect things together with nice tangent geometry. The question in the chat, does Rhino use STL and FBX file types? Some nice has. Yeah, it exports and imports pretty much all of the polygon geometry types like those. So those tend to be your output in the end is a triangulated polygon mesh with a high enough resolution to make your printer happy, or a step file or other NURBS type of file that's more of a mathematical description of it instead of just a big series of points. And those are useful for things like pathing inside of CNC milling software, or sending out layers of vectors to create on a laser cutter, that kind of thing. But yeah, if we were going to make this on the 3D printer, we would usually mesh it. There's a triangulated mesh. We might go higher resolution than that, but that doesn't look terrible. And then export that as an STL. It'll automatically mesh it for you as you go out to polygon formats, but I like to mesh it in advance so that I can kind of control what my resolutions look like. But yeah, that would be, presuming that's a closed mesh, which it isn't right now because of whatever error I made, that would be what you'd send over to your 3D printer. All right, and I think that does it for our third little CAD and modeling basics. Let me know in the chats if you have questions or topics you'd like to see covered. I will try to hit those, and eventually we'll make something practical that fits, one of these here microcontroller boardy kind of things that we have, and do some actual fabrication. Right. Thanks everyone so much. Before I go, I will remind you that you can eat delicious candy corn this time of year. It's the only time of year you're allowed. And you can get 10% off at the Adafruit store by typing in candy corn in your coupon code slot on the way out. So head on over to adafruit.com, grab some cool stuff that you want, maybe some parts for building one of these suckers. I don't know. And then you'll get 10% off with that coupon code. Another question someone asked in the chat. I'll take questions, so bring it on. The Dave Odessa question over in the chat. Are you using the latest version of Rhino? I'm not. I'm using Rhino 7. Rhino 8 came out not too long ago. It has some neat features and it has some glitches, so I'm kind of staying with 7 for the time being, but eventually may move to 8. We'll see. Let's see. Some Boolean discussions. And some bread. Thanks for the making me hungry there with the delicious, delicious bread. Is that a boule? Is that French for bread or a bread shape? I think it's French for a bread shape. All right. Someone, Andy said they're using QCAD and LibreCAD, and they cut their teeth on MicroStation. Very cool. We're going way back. I came from Alias Studio, which was a NURBS modeler for like automotive and industrial, and then Power Animator, which is kind of what led into everything in the animation business, and Maya, which I used for a couple of decades. But Rhino kind of comes out of that NURBS world originally. Now it's got kind of all different geometry types, but I like it, especially with the advent of Grasshopper, which we'll get to. Okay, thanks everyone so much for stopping by. Don't forget, we've got other shows happening, like if Scott doesn't suddenly have a baby, he's going to be doing a deep dive with Scott tomorrow. Foamy Guy broadcasts Foamy Guy live streams often on the weekends and other times, I think. I'm not sure. When do you do that, Foamy Guy? We've got a Desk of Lady Ada often on the weekend at Mysterious Desk of Lady Ada times. Regularly scheduled shows include the Product Pick of the Week back on Tuesday, the 3D Hangouts on Wednesday, Show and Tell on Wednesday evening, and Ask an Engineer after that. So a bunch of stuff to come out and see. Thanks everyone for hanging out with us. I appreciate you, and I will talk to you next time for Adafruit Industries. I'm John Park. This has been John Park's and Lars's Workshop. Bye-bye.
Thank you.